So in this video, we will discuss about the contingency table, and for that we are going to solve this problem. So a sample of 420 employees of a company were asked if they are smokers or non-smokers and whether or not they are university graduates. Based on this information, the following contingency table was prepared. So there are in total 165 university graduates, you can see, and out of that 35 are smokers and 130 are non-smokers. Same way you can find out how many are non-university graduate, and out of all the non-university graduates, how many are smoker and non-smoker. So we will solve this problem here. So if one employee is selected at random from this company, find the probability that this employee is a university graduate. So total number of university graduates you can see here is 165. So 165 is the total number of graduates, and the total number of employees is 420. So it is your 420, and therefore the probability that the employee is a university graduate is 165 over 420. Right. Next is, what is the probability that this employee is a non-smoker? So total number of non-smoker are 305. So we can see 305 and out of 420. So we can write here as 305 out of 420. Now, what is the probability that this employee is a university graduate and a smoker? So we have to find the intersection of university graduate and the smoker. So university graduate and smoker. So this is the intersection. So 35 out of 420. So your answer will be 35 out of 420. Right, so out of 420. Then the fourth one, it is your a smoker given that he or she is a university graduate. So this is a conditional probability. So where it is already given that the employee is a university graduate. So your sample space reduces from 420 to only number of university graduates, and we have the total number of university graduates as 165. So out of that, 35 are smokers. So your probability will be here as 35 over 165. Right, and not a university graduate given that he or she is a smoker. So now we have a conditional probability where it is given that he or she is a smoker. So smoker is total 115, and out of that 80 are non-university graduate. So you will get 80 out of 115. Now we can consider another problem where the table shows the number of athletes who stretch before exercising and how many had injuries within the past year. So you can see the number of injuries written and no injuries written for last year, and number of athletes who does stretches and who does not do stretches. So that also is written. So total 800 athletes are there. So we have to find the following probabilities. Now we randomly choose an athlete. What is the probability that the athlete we choose does stretches? So the total athlete who does stretches is 350 out of 800. So your probability here, it will be 350 out of 800. Now we randomly choose an athlete. What is the probability that the athlete we choose had injury in the last year? So injuries, total number of injuries is 286 out of 800. So here what we will get it here is 286 out of 800. We randomly choose an athlete. What is the probability that the athlete we choose does stretches and had injury in the last year? So it is your and here. So we will see the intersection here. So stretches and injury, so which is 55 and out of 800. So your solution here will be 55 out of 800. Right now, so the next, we randomly choose an athlete among those who do stretches. What is the probability that the selected athlete had no injuries last year? So we selected the athlete here who does stretches, right? So you can see here the athlete among those who does stretches. So the stretches they do is only 350. So your sample space is now 350. And out of 350, who had no injuries last year? So that is 295. So you will get 295 out of 350. The second one, we choose an athlete at random knowing that the person we selected had injuries last year. So this you already know. So that means this is your conditional probability. So we had the injuries last year. So we already know that the person has injury last year. That is your sample space is reduced to 286 and you have to find he or she does not do stretches. So they does not do stretches is 231. So the solution will be 231 out of 286. Now the last one, what is the probability of selecting an athlete who does stretches or had no injuries in this last year? So we will apply the addition rule here. So we will see this word as or. So the person or the athlete who does stretches and or had no injuries. So we will find the probability of an athlete who does stretches first. So which is 350 out of 800. Then we will find the probability of the athlete who had no injuries last year, so which is 514 out of 800. And then we subtract the intersection, that is the athlete who does stretches or and had no injuries, so which is 295. So my answer will be here as 350 out of 800, which is probability of an athlete who does stretches. Then probability of an athlete who had no injuries last year is 514 over 800. And then we subtract the intersection, that is the probability of an athlete who does stretches and no injuries last year, which is the intersection, that is 295 over 800. So you can simplify this one and you will get the probability of an athlete who does stretches or had no injuries in the last year.